Somewhere in the library, an insect is eating the books, or at least that's what it's been charged with. Booklice, insects defined by the harm they do to paper. Walk into the reading room of almost any old library, lift a volume that has sat too long in a damp corner, and you may find them, usually pale, translucent specks moving in the bindings, so small they can be mistaken for dust. They are members of what used to be called Psychoptera, now called Socodia. The overwhelming majority of book lice live outdoors on bark, leaves, and stone, raising algae and lichen and fungal spores off surfaces, harming nothing and noticed by no one. A small handful came indoors with us, and one species in particular, Liposcellus bastricophylla, became the face of the family in every library, granary, and museum store on the planet. The charges against it are long. It infests herbarium sheets, entomology collections, books and manuscripts, cardboard boxes, and furniture. It contributes to the degradation of library and archive collections through feeding, through the frass and cast skins it leaves behind, and through the fungal spores it carries from place to place. At the Royal Botanic Gardens, more than half of all the antique collections arriving at the library come already infested, which means nothing can enter the building without decontamination. The Sosids come in enormous numbers, in some of the most carefully guarded paper collections in the world. So what's going on here? How do they invade in such numbers when everyone is on alert? In populations of Liposcellus bastricophylla, there are no males. A female produces roughly 200 eggs, each one functionally a self-fertilizing clone of her mother. The consequences for a library are severe. One insect arriving inside one book becomes a colony seemingly overnight. The insect doesn't even need to drink. It extracts water from the air. And this is the hinge on which the entire conservation problem moves. An organism that harvests atmospheric moisture is an organism whose survival is set by relative humidity. Once relative humidity dips below 50%, the population starts dying off. For an archivist, you don't need to kill the insect. You only need to make the air too dry for it to drink, and the insects go away on their own. Which is good because the group is incredibly resistant to pesticide. But what does an uncontrolled population of book lice actually do to a book? Researchers set up an experiment to intentionally grow book lice on damp papers for a year. In some of the samples, fungus took hold, and in those samples, the population of insects exploded. 49 days after the insects were added, the population went from 96 to almost 6,000 insects. But in the samples without fungus, barely anything. Fewer than 8% of all the insects introduced to the paper and glue combination were alive at the end. Those that were began eating each other. The paper is not food. So it turns out the insects ate the fungus, and when the fungus was gone, the paper underneath it couldn't sustain the insect colony. These insects are fungal grazers that happen to graze on your book, and only when your book has become a fungal substrate. But there is a snag. It's possible that old books could be susceptible. Historic paper is different than modern kinds. Old book pages tend to be made of pulped cotton and linen instead of wood pulp paper. They are also bound in organic animal glues. It's possible that these old books and documents are susceptible to book lice in a way that modern paper isn't. But there is a difference between the insects are present in the books and the insects are consuming the books. But the book louse is almost certainly not eating any of your modern books. What it is doing is telling you something you would otherwise not know, that the air is wet enough to grow fungus, and the fungus is growing. The mold will damage the collections. The mold will damage the building. The book louse is simply the first organism small enough and fast enough to notice it. If you kill it, you have broken your own fungus alarm.